Okay, so we're going to start today by multiplying binomials times binomials, binomials times trinomials, just polynomials times polynomials. So it's all about multiplication for the next couple days. We're going to look at this today in two different methods, one being the area model and the other being the distributive model. And you'll be able to decide which one you want to use. But I do want you to explore both methods today. Some of you will decide that one way is easier than others, and that's fine. It doesn't make any difference how you get there. You just need to get there. So go ahead and simplify these two expressions and write them in standard form. Remember, you're going to be applying the rules of exponents as you simplify. All right, let's see how we did. So this is a 6x5 because we're adding our powers. Minus 6, 2 and 1 is 3, and the last one would be an 8x squared. And the nice part is that is already in standard form. This next one, negative 15, k4, m3, plus 10, k squared, m cubed. And that one is done. Okay, so as we start looking at multiplying binomials or trinomials times trinomials, binomials times trinomials, anything other than a monomial, I want you to just think about the area of a rectangle. So if this was 4 and this is 5, we know the area would be 4 times 5. So 4 times 5 would be 20. Well, if this was x and this was 5, wouldn't the area still be the same? It'd still be multiplied, right? So this would be a 5x. So whether we have numbers or we have variables, the process doesn't change. Well, what if this was x, and this was 2x plus 3, and this was 4, and this was 3x? How would I get the area of the shaded region? Well, this first part is really a distributive property. So I have x times 2x plus 3, which would be a 2x squared plus 3x. And then if I multiply these two, I have a 12x. So that would give me 2x squared plus 15x. So I'm really still multiplying monomials times monomials. I'm just thinking about it in terms of an area model. Okay, so let's take a look at the area model with a binomial times a binomial. So remember, a binomial is our two terms, okay? A two-term polynomial. So we have a binomial times a binomial, and notice how I have x and the plus 2 and the x and the plus 5, and I did write the signs there because I want to keep track of my signs. It's important when we're doing this method to kind of keep track of your signs. And we're going to just figure out the area of the box. So remember, this is a 1 and this is a 1. So 1x times 1x, well, that's a 1x squared because powers of 1 are going to add. And now I'm going to go to this box, which means I'm multiplying here and multiplying here. So 1x times 5, that's a 5x, and it's a positive 5x. Okay, now I'm going to go down to this bottom box. I'm multiplying the 2 and the 1x. So that would be a positive 2x. And then if I go to the last one, I'm multiplying the 2 and the 5. That's a positive 10. Okay, that's a positive 10. Now what I want you to notice, okay, is that right here in the center is a giant plus sign. And that's important because those are like terms. Those are like terms. So to pull the answer out of this one pulls out, so 1x squared. 2x plus 5x, that's a positive 7x, and the plus 10 pulls. So here's my answer, 1x squared plus 7x plus 10. Okay, let's do another one. X minus 3, 2x plus 1. And remember, we're going to write our signs. And remember, this is a 1. So 1 times 2x, that's a 2x squared. And 1x times positive 1, that's a positive 1x. Now I'm going to go to this bottom box, so I'm coming down this way. 2 times negative 3, that's a negative 3x. And my last box are coming here, so that's going to be a negative 3. And again, I'm going to combine on the diagonal. There's my plus sign. Top number pulls out. So 2x squared, negative 3 plus 1 is a negative 2x, and my minus 3 drops out, and I'm done. Okay, go ahead and try this next one on your own. Okay, let's see how you did. So I wrote 2x minus 4 down the left, 3x plus 2 across the top. First box is 6x squared. Second box across the top is positive 4x. Bottom box, negative 12x. And last box is negative 8. Combining on the diagonal, excuse me, 6x squared minus 8x minus 8. So hopefully you came up with 6x squared minus 8x minus 8. Okay, let's do a couple more. Three more. I'll get you started on the first one, and then I want you to do all three of them and then touch base with it. Come back to me here, and let's see where you're at. So this next one, I want you to see that this is power of 2, and I want you to remember that means there's actually 2 of them. So that would mean I'm multiplying 3x plus 2 times 3x plus 2. So that would be, that's going to look like this. Okay, so go ahead and hit pause and solve these 3 and then come back and check your answers. All right, 3 times 3 is 9x squared. I have a 6x. Notice those are exactly the same, and a positive 4. So my solution on this one would have been a 9x squared plus a 12x plus 4. X minus 3, 2x plus 3, 2x squared, positive 3x, negative 6x minus 9. Again, combine on the diagonal. 2x squared minus 3x minus 9. And this last one has lots of variables, so I need to make sure and not lose them. So negative 6x squared, a negative 4xy, remember x comes before y, a positive 9xy, and a positive 6y squared. So negative 6x squared, a positive 5xy, and a positive 6y squared. So hopefully that went well. Okay, let's do one more in the area model before we look at the distributive model. And I think the area model is really helpful if you're not real organized. So if you struggle kind of keeping your work organized, then the area model is probably going to be the one you want to use. And I think it is definitely easier to work on larger multiplications. So when I'm multiplying a binomial times a trinomial, I'm going to have 6 terms. It does a nice job of keeping things organized. And if I was to do a trinomial times a trinomial, where I'm multiplying 3 terms by 3 terms, it would definitely be easier. So it's kind of up to you, but this definitely helps keep things organized. So x plus 2, your x squared plus 3x minus 8. Go ahead and hit pause. See what you can do with this one. This one has 2 sets of diagonals. See if you can discover what the combining of like terms is going to look like on this one. Okay, first one, x cubed. 3x squared minus 8x. Bottom, positive 2x squared. Positive 6x minus 16. Again, important to keep your signs. That way you know what you're combining. And again, 2 diagonals, okay? So pop out that first one and then combine. 2 plus 3 is 5. And a negative 2x and a negative 16. Now, not always will they be on the diagonal. It just depends on the order of your trinomial. But primarily, you will see them on the diagonal. It's just an exception when they show up on the other side. Okay, let's take a look at the distribution model. Okay, so this one I just want you to look at. And this is going to show us a lot more work than what we really need to do. But I want you to see what's happening. Okay, so if I take and I distribute the x to both of these pieces, the first thing that's going to happen is x is multiplied to the parenthesis. But then the x has to multiply to here and here. So I need to distribute to both pieces. The same thing happens if I take the 3. If I distribute it to both pieces in my parenthesis, I have 3 times the x and then 3 times the 2. So it's going to go here and here. So here's my x squared. There's a 2x, there's a 3x, and there's a 6. So I see that my x squared drops. I see these are like terms, and I'm done. Okay, now that's a lot more work than what we really need to show. Most of you probably can do a lot of this in your head if you're organized and don't lose your signs. Okay, so I like to call this the double distribute method, where you're going to multiply the top. So y times y is y squared, and y times 2 is a positive 2y. And then you're going to use the second number and do the bottom distribution. So negative 5 times y, and I'm going to go ahead and write this one underneath because I like to combine down. So negative 5y, and then a negative 10. And I've got y squared minus 3y minus 10. And there's my answer. So if you don't want to make the box, that's fine. This vertical method works. Let's try it again on this one. So again, double distribution, the top part, and then the bottom part. So I have a negative 3c squared. This one I'm going to go ahead and just go horizontal so you can see what that looks like. 3 times 3 is 9. And then I'm going to do the second one. So I have a negative 2c squared and a positive 6. Combining my like terms, I see that this one, this needs to be a 4. Minus 3c4. These two are like terms. So plus 7c squared plus 6. So again, your choice. Area model or the double distribute, writing vertically or writing horizontally. It doesn't matter which way you prefer. Okay, so why don't you go ahead and solve this one? And I don't care whether you want to do it with box or whether you want to do it with distribution. I'll probably do this one with distribution. Actually, I think I'll do it both ways so you can see what it looks like and you can decide which one is best. But you can decide right now whichever method you want to use. If you're going to use a box, make sure that you draw a 3x3 box because we have 3 terms. And if you distribute, you're going to have to triple distribute. So multiply 3 times. So go ahead and hit pause and see what you can do. Okay, so I'm going to go ahead and start with the box method. So I multiply, I put the left one, right one. So the first box is x4, negative 2x cubed, plus 3x squared. I'm going to go to the next row, plus 3x3, minus 6x squared. And notice I'm looking to make sure that my powers are lining up, and they are. 9x, minus 4x squared, minus 8x, minus 12. Okay, so combining, I need to combine here, here, and here. So 3 spots, okay? So the x4 is going to pop out. I have 3 minus 1. That is a positive 1. So I'm just going to write an x cubed. I have a negative 4, a negative 6. That's a negative 10. Plus 3 is a negative 7. X squared. Notice the powers are not changing. Negative 8 plus 9 is a positive 1. And I have my negative 12. Now, some of you are really going to like that method because it's super organized. I don't have to worry about which ones go together. They're in a line. It is entirely, again, it's entirely up to you which method you use. It's whichever way your brain works best. Oops, let me get back to where we were here. Okay, so if I'm going to distribute, I need to distribute 3 times. So I'm going to go ahead and get this out of the way because I'm going to need a little bit more space. Okay, so I'm going to start by doing my x squareds. So that is x to the 4th minus 2x cubed plus 3x squared. And I'm definitely going to write this one vertically. Otherwise, my expression would be covering my whole page, and I don't want to deal with that. So now I'm going to go here. Plus 3x3 minus a 6x squared plus a 9x. That's my double distribution, but I have not dealt with my third one. So I need to now take my 4 and distribute through. So negative 4x squared. Notice how this is moving over 1 each time. A positive 8x. And did I lose a sign over here? Oh, I did. So then we need to change that guy. That's a positive 17x. And minus 12. So x4, my x3, my negative 7, that's a power of 2, the 17x, and the minus 12. So let's fix that side. Look how easy it is to lose signs. It happens. Okay, so let's go ahead and work on some homework today. Again, I don't care which method you use. You just need to make sure and get yourself in an organized manner to kind of keep track of these larger polynomial multiplications. Reach out to us if you're struggling.